Anyway, it's a pleasure to be here, and acknowledge the power behind the legend here, Deb, for being here. She's right up front now today. Always a pleasure to see you. Anyway, I'm talking about P2P, because Ken and I worked together with John Bickley on P2P, and that was coined as pre to posthumous concrete. But first, I've heard people mispronounce your name before. And so some people call you Hoover, there's a Hover, so a Hoover's on the left and a Hover on the right, so just throw that in there. Because there's a lot of confusion in the crowd. People say, where's that Hoover guy? Anyway, I was lucky enough to work with John and Ken under a P2P project for NRMCA, God, almost 20 years ago. And we're three wearing ties. Anyway, we're involved for several years doing several reports for P2P. And we involved several meetings where Ken came up to Toronto and we sat in John Bickley's office, and then one time we met in, I think, Batavia, New York on the highway in a dirty motel for 3 days doing the same thing. So it was a lot of fun. We laughed a lot because just to extend this thing about having fun. So anyway, we did these reports, and these are quotes from some emails that I got from Ken at the time when we did it. He says, it's a beautiful thing. And we've got paternity and custody of that report. And he says, reading pleasure, in case you've been sleeping, you can have trouble sleeping, you can put this report in your nightstand, and do the job, you'll wake up refreshed. But anyway, we had a lot of fun doing these reports, and it was always fun to get an email. So the title comes from a slide presentation that Ken made to SDC, I believe in Niagara-on-the-Lake, way back, when we were first starting this, and he talked about where do we need the quality, before the shoot or after the shoot? And he coined that posthumous concrete is what we're looking for. So that's the bit. And he said there's a whole bunch of serial steps you have to go through to get posthumous concrete, the pre-shoot steps, and then move over to the post-shoot steps to get there. And that impacts on all these things impact on the performance of the concrete. And by the way, I didn't get the memo about 5 slides, so I got more slides. But anyway, seriously, there's a whole bunch of things that happen after the shoot that impact quality. Who knew? And that becomes probably even more so now we're talking about low carbon concretes more and more. There's a lot more things that have to be taken care of on the concrete on site. And people talk about performance. When we were doing this thing, Ken showed this slide about where do you do the testing. Do you do it when you're qualifying a mix? Do you do it when it arrives on site? Do you move it after it's been ready into the placement, or in place in the final project? And of course, the owner is interested in the one on the right. The owner doesn't care about the end of the shoot, but the concrete industry doesn't want, it's a change of ownership from the concrete producer to the contractor to the owner. So the change of ownerships, you have to have different points of performance. So when we talk about P2P, John and Ken and I were talking about the one on the right, but our mentors at NRMC were only interested in the second one. So it's pre-shootimus. And of course, the owner only cares about the post-shootimus concrete. And unfortunately, when 329 formed, they had an ITG and then formed ACI 329 on performance of concrete, their scope is to the end of the shoot, unfortunately. There isn't a post-shootimus committee 329B. So that's one of the shortcomings of that thing. Anyway, so some of the things we talked about is allowing, if you're going to have performance testing, you have to have performance limits, and you have to have performance limits. You need to allow for variability because all tests vary. And it's the way we do it with strength. We talk about allowing for under-strength cylinders based on, just like this thing, you target a higher number than your F prime C, and in-place cores, if you don't make it, you do cores and you allow 0.85 of the F prime C to be accepted. And you can do the same thing with air content. With target air content, we typically, for a concrete we place in Canada, we target 5 to 8, and a producer would probably target midpoint, but you'll accept 3.5 in the hardened concrete. I think ACI actually allows 3, and the same thing if you're going to do hardened air voids, but that's post-shootimus. We do that in Canada. We have a specified air cont average spacing factor. A producer would target something less than that, but we'll accept a running average of that value with a higher single value because there's variability in the test results. So he's using the same approach for if you're going to do performance and post-Hooton concrete, and we do the same thing in Canada for Coulomb limits for permeability, which we require for all the equivalent of ACIC 2 concrete. So you'd have a specified limit, and you have a running average and single value that you accept in for quality acceptance in the hardened concrete. And some of the things we talked about with performance, post-Hooton performance, is defining the roles and responsibilities of all the different players in this game as it moves down the line from concrete to contractor to owner. And so the Canadian standard actually has that. We actually have post-Hooton performance in the CSA standard. And we include all these roles and responsibilities defining that, establishing the requirements for the producer, encouraging the interaction between the contractor and the producers to get together because they both impact on performance. And allowing that flexibility for performance allows them to do interesting things that they couldn't do in a prescriptive spec. And allows, especially when you're talking about new types of concrete, low carbon concrete, performance specs will allow for more acceptance of that type of thing. And you've got to set requirements for the acceptance. Okay. Everybody targets 28-day cylinder strengths cured in a laboratory on 6x12s, but that's not an adequate metric for performance. Construction doesn't care about 28 days. They care about when they can strip the thing. If you're doing vertical, they want to know when you can remove shoring. And so 28 days is not a good construct or metric for what we're interested in. And so we need to move on from that. And we allow for later age strengths for low carbon concretes to develop their properties, because 28 days is a Portland cement concept. It's not a concept for concretes with SEMs. And if you're going to put all your specs at 28 days for all the properties, you're not going to take up the value of those concretes that we're producing today. And cylinders don't represent the structure. And a lot of concretes, they say, well, these high SEM concretes, you reduce the early age performance, but that's only in those cylinders in a constant temperature. But if you're building a structure with anything like a column or anything massive, they're developing strength way higher than that because they're thermally activated. And so the cylinders in the lab do not represent that performance. So we need to think about that. And we tried to introduce performance at 318A because right now the C2 in 318 only requires 0.4 water binder ratio and 5,000 psi at 28 days. Neither one of those relate to durability, but that's the only requirement for concrete in a chloride exposure. And this, late Mike Thomas's data, but just to represent that doesn't represent the performance in terms of what we're interested in, because here's permeability just by the Coulomb test, water binder ratio, so all, that blue line represents 0.4, they'd all meet 5,000. Portland cement concrete, fly ash concrete, a slag and silica fume concrete. Completely different performance in terms of time to corrosion. The top one, we'll probably get 10 years before it starts to corrode. The middle one, maybe 30 or 40 years. The bottom, maybe 75 years. But they're all exactly the same as far as C2 and 318. Because 318 doesn't have any performance requirements, unfortunately. We tried to do something about that, but unfortunately, there was a lot of resistance to adopting that, so the new code that will come out next year will still be 0.4 and 5,000 psi. We tried to even relax the water cement ratio and strength if you met a permeability limit, but that didn't fly. And a lot of the pushback was because they don't trust the testing industry. The producers don't trust the testing industry. They say the testing of strength is bad enough, let alone more complicated tests. So that was the part of the pushback, a major part of the pushback, and that's unfortunate. And so that led Ken to be less than happy with post-Hooton. So we have the pre-Hooton smile and the less post-Hooton not smiling on the smilometer. In fact, he looks like he might be a hitman on the right. Anyway, I will finish up. Anyway, it's been great to work with Kenneth on several opportunities to work with Kenneth. It's been a lot of fun and impacted my work. But also, just at the end, since everybody's going to 3D printing, I'm glad that we're moving back to 2D printing for Ken. So thanks very much, Ken. Appreciate it.